Everyone, I'm More Blessing Nyirenda. I'm presenting my project to you, Solar PV Monitoring System using Arduino Uno Rev 3. This is the picture of my completed project. As you can see, I have the Arduino Uno on the board and the Wi-Fi module ESP12F. Initially, I wanted to incorporate the Wi-Fi module in the circuit, but due to time constraints, I could not finish working on the code. On this side, I have power connectors for solar panel, DC to DC converter, battery, and the load. Underneath there, there's resistors for voltage divider circuit to step down voltage from 17.58 volts to 5 volts, which is self voltage for the Arduino to operate. The Arduino will be powered by 5 volts that is coming from the PC through the PC printer cable. Now let's look at the hardware block. The hardware block consists of solar panel with a rating 10 watts, 17.8 volts, the DC to DC converter, 12 volts, 7.2 amp hour battery, load, and the monitoring system. The monitoring system consists of 3 sensors, which are going to measure temperature, voltage, and light intensity. The temperature sensor, which is going to measure temperature, is LM35, and the Arduino is going to measure the voltage, and the light intensity values are going to be measured by the light dependent resistor. And all these values are going to be read and processed by the Arduino R3, which is later going to relay the values to the serial monitor for display. The flowchart. The flowchart of the program also shows the program mainly dealing with the voltage conditions. The sensors are going to be read for voltage, light intensity, and temperature values, and the Arduino Uno is going to process the information and send the data to the serial monitor for display. But before it does that, the code in the Arduino has to go through a series of loops and come up with before it comes up with the display. In this particular project, it's going to ask, is the voltage from the PVC system more than 16 volts? 16 volts is the maximum voltage that I chose for the system. If it's a yes, it's going to display maximum voltage exceeded and then battery feed customer. And if it's a no, it's going to check another loop again. Is the PV voltage range between 16 volts and 11 volts? And if it's a yes, it's going to state system healthy. And then if it's a no, it's going to check another condition again. Is PV voltage equals to 5 volts or lower than 5 volts? If it's a yes, it's going to display on the serial monitor low voltage or system faulty. This is going to act as an alarm to alert the person who is monitoring the system that there is definitely something wrong with the system, because the voltage is way now much lower. It's now either 5 volts or lower than 5 volts. This prompts the person to do fault finding and rectification. And if it's lower than 5 volts, it's going to check again, is the PC voltage equals to 0? If it's a yes, it's going to state on the serial monitor system down or no sunshine or fault on the system. This again is going to act as alert system for the person who will be monitoring the system to check whether there is no sunshine or definitely there's an open circuit somewhere along the system. Now let's check the circuit diagram of the project. The circuit diagram shows how the components are wired on the circuit. This is the Arduino Uno. This is the Wi-Fi monitor module, and here these are the resistors for the voltage divider circuit. The voltage divider, the one that steps down voltage from 17.8 to 5 volts for the Arduino. And the output from the voltage divider is connected to the A2 analog input for the Arduino. And here we have the temperature sensor. The temperature sensor is connected to the input pin A1, and the light intensity sensor is connected to the input pin A0. Monitored parameters results. The monitored parameters, the solar panel was tested under 3 different conditions: under sunny weather condition, shaded condition, and dark conditions. And from those 3 different conditions, we actually see there are different values that have been obtained. Particularly, let's look at the voltage. The voltage shows that there is a big difference between the values obtained under sunny weather than the one under dark conditions. So if you want to get optimum results and higher efficiency from a solar panel, you have to check the conditions that you install the solar panel under. Future works. I wish to incorporate the Wi-Fi system for data to be accessed wirelessly and to measure current, to merge the monitoring system also with on-grid systems, to keep on working with renewable systems such as solar PV systems, and to help other students with their solar-oriented project. Thank you so much. This is my presentation.